What? We just spent the past, I don't know, however many minutes it took you guys to watch those videos, learning about IPv4. What's the difference between IPv4 and IPv6? Well, IPv6 has a higher number, and it's newer, but there's a lot more than that. I'm gonna let Past Steven take it from here. Welcome back, boys, to another episode of Low Spec Labs. On today's episode, we're gonna talk about the IP protocol. So a couple videos ago, we started talking about IP addresses and subnetting. Let's talk about what exactly IP addresses are. So remember, a protocol is a set of rules that defines how things communicate. So the IP protocol defines how internet devices communicate. And IPv4 is the fourth edition of the internet protocol. The reason I mention IPv4 is because there's actually another version of the internet protocol called IPv6, and that's what we're about to dig into. So IPv4 versus IPv6. IPv4 uses a numeric decimal notation. IPv4 uses DHCP, where you manually configure it. IPv4 uses a 32-bit address, so 8 times 4 is 32. IPv4 allows up to 4.3 billion IP addresses, which would normally be enough, but thanks to phones, cell phones, routers, and all the other internet devices we have connected today, we are actually running out of IP addresses. IPv6 is the official solution for us running out of IP addresses. Before that, we had a couple other stopgap solutions. For instance, we had port forwarding, we had port address translation, we had NAT, right? Lots of different methods for us to get more IP addresses. But why mask or hide your IP address or translate it when you can simply have the IP just listed there? IPv6 is also easier on your routing tables, right? It's pretty straightforward. It has a prefix, a subnet, and an interface. It does not have a subnet mask, right? So when you see an IPv6 address, what you see is what you get, basically. Another cool thing about IPv6 addresses is that they are globally routable. So basically, when it comes to IPv6 addresses, that IP address is a public IP address. If you were to ping that IP address, it would actually respond back. Where if you were to ping 192.168.5.18, you would probably get a completely different IP than that, if you got a response back at all, because IPv4 uses public and private IP addresses. So as part of the IPv4 protocol, it has a set of IP addresses it considers private, which will not be routable on the internet. And as part of the IPv6 protocol, all addresses are public, right? So every address in an IPv6 protocol is publicly routable, except of course for the special occasions when it's not. You know, there's always exceptions to things. So the primary differences between IPv4 and IPv6 comes down to IPv6 uses a alphanumeric hexadecimal notation. Again, IPv6 is a 128-bit address, so it uses letters and numbers. Another thing to note is IPv6 uses colons instead of the dots. Remember, an IPv6 address is 128 bits. The first 64 bits identify the address of the network, and the last 64 bits identify the address of the node. So you could consider the first 64 bits something like your phone number's area code, and the last 64 bits as your actual phone number. And let's break that down even more. The first 64 bits are your IPv6 network ID. Of those first 64 bits, 48 of them are your global unicast address. Basically, that's the part of your IPv6 address that is identifiable to the internet. The last 16 bits could be considered your subnet. That's the portion of your network that would be controlled by your network administrator. And then the last 64 bits are your interface ID. And there's even more rules about how all this breaks down, how you get the interface ID. IPv6 can get very complicated, and as a result, most network administrators actually prefer to use IPv4. Generally, they like that because it just works. And remember, if it ain't broke, don't fix it. So let's break it down even more. The first 48 bits of your IP address have a name. So let's break it down even more. The first 48 bits of your IP address are known as your global unicast address. This part of the IPv6 address is actually what's routed on the internet. The next 16 bits are known as your unique local address. A unique local is internal to the network, right? So it's either inside your network or inside your VPN, but it is not routable around the internet. So this 16 bits right here is internal to the network, but is not routable. The last 64 bits are your link local. So these are local networks. So it'd be equivalent to the 192.168.0.0 network, while your unique local would be equivalent to something like 10.0.0.0/16 or /. So unique locals are a wider scope of IPv6 addresses than your link local. Your global unicast address is routable on your internet, and your unique and link local addresses are not routable on the internet. They are the equivalent of IPv6 private addresses. Something to also note is that all IPv6 addresses get link local addresses. Even if there is not a DHCP server, they're still going to get those unique local addresses as part of the IPv6 protocol.